Okay, so up till now, mainly we looked at Hadoop 1, right? We have looked mainly Hadoop 1 in detail. We looked at various configurations in Hadoop 1, right? So as I said, it will not be possible to cover everything again in Hadoop 2 because of time constraints. So everything remains valid what we have done in Hadoop 1. For example, OIV viewer, checkpointing concepts, right? Meta save, the quotas, the users, right? Everything remains same. But in Hadoop 2, we will be covering about things which has been newly introduced into it, like high availability, the yarn and all, right? So let's get started. So a little bit recap from yesterday's session. Yesterday we talked about Hadoop 2.0. I gave you a very brief introduction about how we set up it, right? Using which config files goes where. But I will today walk you through in little bit more detail, and we will set up a distributed Hadoop 2.0 cluster. Then we will run the jobs and see how actually the jobs are being created, how it is different from the old structure, right? And we also looked at little bit of the yarn flow. Yarn flow means we talked about that now job tracker is the not the one which is bothered about the location of the file, right? So delegation has been done and that role has been given to an application master. So agenda for today's session will be mainly we will be talking about Hadoop 2 yarn and high availability setup using both shared storage, Zookeeper, and if we have time, I will also show you Hadoop upgrade, right? From a previous version to a newer version, right? Upgrading within the same version is very straightforward. For example, upgrading Hadoop 1 to Hadoop 1.1 or 1.2 is very straightforward. Upgrading within a 2 is again straightforward. So what we can do is I will show you an upgrade process from Hadoop 1 to Hadoop 2, and I will show you what all configs we need to put and what all things we need to take care of. So yesterday mainly we touched upon these things. The configuration files have been moved to a new location in Hadoop 2 to go in line with how the structure of Linux is, right? All our configuration files go under etc. So Hadoop is also started using same kind of a convention where all our config files have moved from config to etc directory. The location of the jar files have moved little bit down, and each jar has been segregated into their specific roles. For example, in Hadoop 1, all jars were directly sitting under our extraction path wherever we have extracted Hadoop. Let me show you. Right, I go to my name node and I log in as the user who runs Hadoop, and I do ls-l on Hadoop 1.2. So here the jars were sitting directly in that path wherever I untar Hadoop. But in the new one, it is not so. They have given it much more cleaner look, much more organized. So etc one change. Second change is the jar which I am talking about. The jars have moved under share. Under share also, you will have categories of jars according to whether it's a MapReduce jar, it is a HDFS jar, or it is a tools jar or a yarn jar, right? Each has moved separately. So under MapReduce, we have this example jar, which we were using for running various examples. Another change which I pointed out was the binaries, right? Now you do not have the binaries directly under bin. They have been moved to sbin, similar to Linux, where you have all your admin commands. Another change, your job tracker and task tracker have been upgraded to resource and node manager respectively, right? I do not have a job tracker and a task tracker in the newer version. And the command line has also changed, right? So I will show you this little bit more detail. Now I cannot do Hadoop-daemon start job tracker or start resource manager. In Hadoop 1, we were using only one single command, which was Hadoop-daemon start for everything: name node, data node, job tracker, task tracker. But now we have two commands or two interfaces, you can say. One is for HDFS, which remains the same, Hadoop-daemon. And now we have a yarn-daemon, which will be for resource manager and node manager, right? This is the change. And the job execution. Another change is job execution. What does it mean? In Hadoop 1, I would simply say Hadoop jar and path to the jar file. But in the newer version, I will say yarn jar. Old command will also run, but when I'm running by yarn, that's the recommended way because we are invoking the yarn framework, right? So let me go into detail of now Hadoop 2. Yesterday we just went through and touched upon it. So now today we will set up a fully distributed cluster. I go to name node nn1.cluster1.com. So one major change in Hadoop 1 is that if my reverse lookup does not work, it will not let me join the Hadoop cluster, right? What does it mean? Let me show you, right? Let me first set up the cluster and then I will show you what does it mean, right? Here DNS reverse lookup is working. In Hadoop 1, it is not mandatory for reverse lookup to work. In Hadoop 2, by default, it is mandatory for a security point of view, right? It is trying to prevent spoofing. So what does it mean? Whenever a data node goes, if you recall from our class 2, what was the process? How a data node registers with the name node? I have a name node, right? And the moment I start data node daemon on any of the machines, it goes and tries to register with the name node. What name node will do? I will come to your question, Ashutosh, right? So here, DN1, I'm when the data node is going to contact name node and say, I want to register with itself. So when data node is sending its request, in that request, it is sending one was cluster ID, right? If it has, right? If it is a new, cluster ID will not be there. Second, it will be sending its host name and IP. In Hadoop 1, it is sending you an IP. In Hadoop 2, it is sending you a host name, fully qualified domain name. So when it is sending that FQDN saying I am dn1.cluster1.com and my IP is 72, name node will do a reverse lookup on the IP to see whether it gets the same name or not. If it is not, it will just fire a shutdown command, right? So I will show you that. So now the question is how I am managing reverse lookup. Okay, let me show you that. So I'm running my repo server, which is also a virtualized box in which I have set up my DNS, right? So this is my virtual box repo. I've given it a name, which is my repo server, which is having my repositories for everything. For example, CentOS 7, 6.5, Hortonworks, Mappa, right? All the repositories are here. And on this machine, I have set up my DNS server, cat etc named dot config, right? So I have set up forward lookup and reverse lookup for my subnet. And I'm saying my DNS is running on 254, which is the node I'm sitting on, repo server, right? And same, I have given the zone files for each. Everything is in my GitHub. You can pull it from there. Right? So I go to my this one. Here you see DNS. All configurations are there, installation, how to do, how to set up, everything. Right? So I have set up reverse lookup as well. Now I'm sitting on name node 1. So let me clear all the logs, whatever it might have. We will start fresh, setting up a Hadoop 2.0 cluster. First thing is we are making sure our profile is set up, right? It knows where Hadoop is. Wherever I untar Hadoop, I'm telling the Hadoop is there. What is the one change which we have done from Hadoop 1? I'm saying the config files will be found now at /etc/Hadoop, right? And another thing is ls-l/user Java. I've installed JDK. So as we discussed in our class 4, why we are using JDK, not OpenJDK. So there were two reasons. One was how the forking of JVM happens, right? The forking of JVM is taken care in a very nice way in the JDK packages, and the forking is very lightweight, right? If I have given, let's say, 2 GB of memory to a JVM, when it forks for a child, it immediately asks for a 2 GB of the memory in the case of an OpenJDK. If it doesn't found, it crashes, gives you an out of memory exception, right? But in OpenJDK, in the case of JDK, it does not happen that way, right? It will just fork itself, and it is knowing it is just an ask, and it just goes down to the actual uses, right? So this is recommended in production. Use JDK minimum 1.6 and higher. And second is there's a command called JPS, which is only available from JDK 1.6 and higher, not before that, right? That was the reason we were using JDK. So now I change to Hadoop etc Hadoop. First file which we modify in Hadoop cluster is always the environment file, which will tell us where I can find Java for the daemon. Why I'm giving Java again here, right? Somebody might ask, the Java is given here also in the bash profile, right? I saw, right? I showed you, right? Then why I'm giving again? So why I'm giving again is this Java which I'm giving in Hadoop environment, it's for the daemon, right? When the daemon forks itself, it carries the same environment with itself. All its virtual threads will be aware of the Java, right? When we do an export in bash, all the invocations of the bash shell will contain that environment variables, right? But not the process invocations within a subdaemon. So that's why we are doing this export Java here as well, right? Other than that, you don't need to modify anything if your system has good memory. In production, we will bump up this memory, but here I'm saying 400 MB is good enough, right? In our cluster is very small, you can work with 300 MB also, 200 MB also, right? But in my case, I have sufficient memory. My base machine is 16 gig, my other server is 32 gig, right? So I can give a lot of memory, but I'm just drilling it down for the sake of participants, right? Other than that, I do not need to change anything. I save it, right? Second change, core-site. This is the file which tells me where my name node will run. In old Hadoop one, parameter was fs.default.name, file system's default namespace server. Which is that? Right, that parameter has changed to default fs file system. Right, I'm saying it will be nn1.cluster1.com port 9000, optional. If I do not give this port, by default it will take 8020. I'm giving 9000 because I can explicitly open ports in firewall knowing which ports are opened, needs to be open, right? But if I don't give 8020, by default it will take. Host name, it is the same host which I'm sitting on. This will be my name node. vi hdfs-site. This is the file which tells me lot of parameters, right? As we see earlier, here I'm telling where my name node will write metadata. I'm saying /data name node directory. Where, what will be the replication? 2. What will be the block size? dfs.block.size, there's a parameter. If we do not give that parameter, it will take default. I can override that parameter. So this parameter which I have given here, if I do not give this parameter, by default replication will be 3. So anybody recall why replication by default was 3? Right, we discussed this, right? If I do not give this value, let's say here, by default it will take 3. Where that 3 value is coming from, right? So I showed you that we did a discussion. Did you remember where that default value is coming from? Anyone? Okay, sure, I will share the document, Ashutosh. So Rohit is saying no, please help to recall. See, I executed the command. If I go back here, pwd ls-l, there's a file called hdfs-default, core-default, mapper-default. But where will it be? Right, by default it will not be directly visible. It will be part of your jar files. So I showed you ls-l in Hadoop 1 also. We went to this directory and I said there's a jar called core. Right, there's a jar called core. So the Hadoop core jar will have all these XML files bundled. For currently what we are modifying is core-site, hdfs-site, mapper-site. If we do not modify them, where all those parameters are coming from? They're coming from core-default, hdfs-default, mapper-default. All those files. Where are all those files? They are bundled as part of the jar with the Hadoop. So how I can see that? I can say jar hyphen ft. It will list me all the file it has. For example, let me grep for default. Right, you can see jar has those files bundled. And then what we did was we extracted one file out of it. I extracted one file out of it to show you what are those parameters. So I don't need to remember any parameters from the top of my head. Oh, sorry, it is xf. Right, x is extract, f is file name. So now it will extract this from the jar, ls-l. Right, this is the file. So I open this file. So this file has all parameters by default. So whenever I specify any parameter in core, mapper site, hdfs site, I'm overriding the default parameter. So here if I go replication, right, dfs.name.dir, replication by default is 3, dfs.replication, block size, oh, sorry, it's block dot size, right? See, 64 MB dfs.block.size. So everything is coming from default files, right? So this we have covered in detail in I think class 4 if you go back and watch the videos. So all parameters are coming from there by default. But what we do is, if I write those parameters in these files, they are overriding the default parameters, correct? So what is happening, even I do not need to give this core any value here inside it, right? To run it in standalone mode, what it will do, if I do not give this parameter, it will run on localhost. It will create this file directory, everything in /temp, right? Which is not recommended in production because temp will be cleared occasionally, right? Periodically. So I explicitly say some location which I can maintain, dfs.replication. So now I save it. Another file which we talked about, okay, we'll come to the yarn part later. So df-h, I have a mount point, ls-l/data name node, it has some data. Let me empty it, right? This is from yesterday's. Let me empty it. We are setting everything again. So now this is empty. I'm checking the ownership, should be Hadoop, obviously, right? The one which with which we are running it. So I will say hdfs name node hyphen format, right? It formats it. Say it has successfully formatted. So now let me show you this. So for the sake of all people who were not there, or let me help you recall. So it will create a current directory. Under that, it will create fs image and a version directory, version file. What will be the version file? It will contain your namespace ID, which is a randomly generated number. This number will never change throughout the life of the cluster. So what does it mean? I will never execute the format command again once I put the data, because this is a namespace unique identifier. This cluster ID is also a cluster identifier, right? Which has been introduced in Hadoop 2. Namespace has been there from the very beginning. This is the version number. Storage type, it is I come to know this is name node metadata storage type. Block pool ID, the IP of the node on which it is running. Right? This information will be there. After this, I go to a data node. Let me connect to any data node. 72. We have 3 data nodes: 72, 73, 74. I go here. CD Hadoop etc Hadoop vi core hyphen site. Same thing. Where my name node is, I'm telling data nodes. Vi hdfs hyphen site. Here what I need to tell. Now instead of, what was the parameter here? It was dfs dot name node dot name dot dir on name node. On data node it becomes data node dot data dot dir, right? And I explained you, and also we did a demo if you remember. So that's why I'm saying please practice at home, otherwise you will forget things. Whenever we give a comma separated field on a data node, it adds to space. What does it mean? Let's say D1 is 4 GB, D2 is 4 GB, D3 is 4 GB, total space will be 12 GB. But in the case of name node, it will not be. Comma separated field, it means write in parallel at both locations. Data node means write in round robin fashion, right? So I explained you the algorithm also, how the round robin is done, and how it matters if we have different disk storages in this parameter, right? Let's say if I have 4 GB, 8 GB, 12 GB, how it will do a distribution. It will write one file here, two files here, three files here, if they are of different sizes. Okay, so anyway, so we have set up this. Save, go back, ls-l slash space. I'm checking, all should be empty. Currently it does not have any data. So now I go to name node. What I can do is I can copy this configuration file scp-r hadoop 2.6 to all data nodes 73 and 74. Right, I will copy this configuration to all data nodes to save the same configuration. I should not be doing again and again. So in production, all this will be pushed through a central repository, right? And RPM will be packaged, which will deploy your base configs or base binaries, and your config files, let's say core, HDFS and all, will be pushed by, let's say, a chef or a puppet, Ansible, right? Those kind of tools. 4, I copy it. So now I have 3 data nodes. It's copying. Okay, so copy has been done. So now I'm sitting on name node into that directory. So I will open vi slave file. Here we will give the name of all data nodes, right? Why we were giving the name of all data nodes? So that when I do start, so one option was we have set a passphrase-less access in Hadoop 1 also. If I do not do, what I have to do is I have to execute start name node command here, then go to data node, start data node there one by one. So if I have 3-4 nodes, fine. But if I have 100 node cluster, it will be very difficult for me. So what I do, I simply write the name of the machines here, set up passphrase-less access as we have done in our class 2, right? So that I can SSH to all nodes from one node and start the services. So I don't need to write any script. By default, Hadoop provides me start DFS script .sh. What it does, it reads the slave file, goes to each node, starts the data node, and the node which I run this script on will start the name node on it. So I will set passphrase-less access. Right, so data node starting, it is giving me message. JPS, if I do here, I can see my nodes up. I can stop secondary because we do not need it. Stop secondary node, right? So why we do not need secondary name node now? Because we will be building up high availability, and I will explain you there why we do not need secondary name node in Hadoop 2, right? But by default, what happens is it is starting secondary name node on the machine which I have configured as a name node, because it does not know whether I will be setting up high availability or not. But once I set up high availability, secondary name node will not come up. You will not see this daemon coming up. Right? So now I go to data node, JPS, data node is also up. I can do HDFS, DFS admin -report. So it is showing me 3 data nodes. Total capacity, live data nodes 3, showing me each data node's storage capacity. Right? So similarly, I will go to now job tracker. or in the new machine it is called resource manager, right? Forget about the host name because I'm using the same host name which we have used for our job tracker, but now instead of running job tracker, here we will be running resource manager. Cd hadoop etc hadoop. What I will do here, vi core hyphen site, I'm saying where my job tracker is. So now the question comes, sorry, where my name node is. Now the question comes, I have explained you yesterday that resource manager is not the one which goes to and talks to name node. Then why we need this parameter here, right? Why we need this parameter here is because this parameter will be passed by the resource manager to the subdomain daemons, saying, okay, you can contact name node this location if need be. Vi hdfs site, I do not need anything. I can only set up replication, but that is also not required. Why this is not required? Because in production, I will always be accessing my cluster from client node, right? And I give you the reason also for that. What was the reason? Why we set up client in our Hadoop cluster? Two reasons. One was security. Second, to have equal distribution of data. Because I do not want that some node should have more data. Because if I can SSH to let's say a data node 1, always one copy of my data will always go on the same node which where I'm sitting, right? Again, we have covered this in our class 3, locality of reference, right? We did a demo also on this when we talked about replication. Vi mapper hyphen site. Here I'm telling that my framework is yarn. That's all. Vi yarn hyphen site. What I'm telling here, these two classes which enables yarn framework. And after that, what I need is just last parameter where my resource manager will run. I'm saying it will run on this node, port number this. These two parameters are optional. But I am showing you I can segregate the resource manager roles itself. I can run scheduler separate, tracker separate, resource manager itself separate. But it will be wasting too many servers for it. I save it. Same thing vi slaves. I will have on this machine also. Here I will say start hyphen yarn dot sh. So it will start yarn for me on all nodes, means it will start resource manager here, and on all data nodes it will start me node manager. So now my Hadoop cluster is up in distributed mode, right? So now what we have to do, we have to bring client in. Client was a machine. What it used to do, it will be a machine which will not run any Hadoop daemon, but it can talk to my Hadoop cluster, right? So what I will do, I will take scp -r, I will copy this entire thing to my machine, to my client. Client is the machine, same setup, Java is there, Linux operating system, everything is same. I am untarring the Hadoop with the configuration files. That's all, right? Same configuration I am copying to my client also. Please go through all our videos, right? First one is not that important, class 1, because it was more of theoretical concepts. Class 2 onwards, please watch all videos again, because all things which we are touching upon have been covered in detail, right? So now cat dot bash profile, I will copy this also. I will go here, vi dot bash profile. What I will do, I will, let me copy all. I'm copying it here. right? So now cd Hadoop ls-l, right? So I will unlink my old Hadoop and I will do a symlink to Hadoop to Hadoop, right? On my client machine. Host name, this one. So in production, this will be the case. Nobody will let you connect to name node, data node, or resource manager, right? Nobody will let you, because one reason, security. It's not safe to let people SSH to critical nodes. So I'm blocking it. Second, to avoid locality of reference happening on any node. So I'm setting up a machine, which are, these clients are also called gateway nodes of Hadoop cluster. I can access my Hadoop cluster through these machines. They will never run any daemon, but they will have the entire configuration copied here. So they will know where my name node is. How they will know where my name node is? From core-site file. How they will know where my resource manager or a job tracker is? From mapped-site in the case of Hadoop 1, it will tell where my job tracker is, and in Hadoop 2 from the yarn file where my resource manager will be. That's all. So now nothing is running here. Let me show you once again. I do Hadoop fs-ls file system listing. It is asking name node, give me the file system listing. Nothing is there. ls-l. Let me copy some data. Hadoop fs hyphen mkdir slash input. Let's create some directory. Cat new client. Let me see what is written there. Okay, cat new data. Okay, something is written in that, right? Cat from client. Okay, so what I will do, Hadoop fs hyphen put new star to input, right? And let's say I will run MapReduce on it, right? So let me open one more session here, maybe from a job tracker. Let's say what I can do is I'm sitting on job tracker. It is running resource manager. It has keys set up because phosphorus access. That's why it was able to do start yarn on all nodes, right? It can go and talk to all nodes, all data nodes, right? And itself. So what I will do is SSH for I in 192.168.72 73, 74, right? We have only 4 data nodes. 69 as well, which is itself do echo $I done, right? I'm just doing a SSH to it. I will do SSH each node. Then I will execute what command? Which JPS? Let me see. Okay, so let me SSH copy -I SSH. This is all Linux stuff, right? Pub. I'm copying to itself. I think I forgot to copy it itself 1.69. So what I'm doing here is simple script which is logging to each machine and checking me what processes are running. I can do this by Clutch also, but I'm not using Clutch. I'm not sure how many of you have used. So in production and all, it is similar to, okay. I was about to say it's similar to a tool used in Yahoo, but people in the audience, there are not many from Yahoo. So what it does is a cluster shell in which I can do SSH to multiple nodes at a time. For example, cat etc cluster shell groups. Here I will define names like this. Grouping. I will say all. So it will go to group NN, which will have NN name node. It will go to node data, all nodes, client JT, right? For example, let's say if I do clush hyphen G group data hyphen B date command. It will SSH to DN1, DN4, all nodes. Give me the time on that. Execute a command on that, right? In production, this is how we will be doing. But for sake of understanding in the class, because as many people might not be from Linux background, and they will get confused at how it is happening. What is data, what is clutch DB and all that. So I'm just simply writing a simple script. I'm running for loop. It is going SSH to each node and giving me an output. Okay, let me make it a little bit more meaningful. Right? Okay, so now our things are set up. So let's execute a job now. Yarn jar path to a jar. If I hit simple enter here, it will tell me what classes I can call, similar to Hadoop one, right? I can call all this, which will see TerraSort, TerraValidate, all these we'll see in our performance tuning session, which is our last class. So I will run here word count. I am saying read from input and write to output. I'm hitting enter here. And let's go to this machine. Job will let the job start, right? So it is starting. Number of splits too. Let me scroll the screen up. So why I've written this script, it will be easy to see from here what is happening. See, MR admin came here, right? See, the yarn child came here, right? So see, job is starting, map reduce is starting. So this script I have written so that it will be very difficult for us to SSH to each machine and show you JPS. So you, the moment you see on JT node, which is source manager, only source manager is running. But then what it is doing, the very first time if you see, it launched an application master. If you go up here, see, application master was launched as I explained. Then it will create a yarn child container which is actually running MapReduce job. How many yarn childs container I will run? Equivalent to number of mappers or reducers I will have. So here I had how many files? Hadoop fs-ls slash input, two files. So I will see two yarn childs here. right? And they will all go the moment the job finishes. So there's no application master, there's no yarn, nothing. Only resource manager, node manager will be running. All other are dynamically created when you submit a job, right? Where it will be created, it will be decided by the framework. Where this yarn child and all that run will, it's saying it ran on data node 2, right? It ran on data node 2. So why it ran on data node 2? Let's see. I do HDFS, FSCK, path, right? It is telling me the state of that file. What is the state of that file? I say files, blocks, right? It will tell me where are the files, what files has, what blocks it has. So it is telling me it has these blocks, replicated twice because replication is 4. Now I will say I want to see the location as well, right? So now it is telling me it is on 72 and 73, right? It is on 72 and 73. So if I go up, dn2 is 73, right? If you don't believe me, let me SSH to that. Let me show you here. ns lookup dn2.cluster1.com, right? It is 73. So it found the file on 72 and 73, two nodes, and it decided that I will go to 73 because data is there. So it will launch the job there, right? And resource application master was launched somewhere else, right? So let me fire another job, right? So this I am saying output 1. I cannot give output again because directory has to be unique, right? Otherwise it will say directory already exists. I hit again enter, clear the screen, let it run. Currently nothing is there because it did not create anything. Running the job. Now resource manager will decide where I should launch the application master. It will fire it to the node manager. Node manager will create this one, right? Again yarn child got created, right? So job is running. So if I show you the output here, mapper 100, reducer 100, Hadoop fs-ls/out. It will write an underscore success file for every success job, and it will write a part file with an R or an M. If it is written by reducer, it will be R. If it is written by a mapper, it will be M. So reducer N, it wrote an output. It is giving me a count of total files. Total files in that, right? So let me just quickly copy one more file, Hadoop fs-put from input. Let's put one more file. And let's see where this file goes. So this file is again going on 72, 73, right? -l Let's copy one more file, test file, and see where this file goes. Right, 73, 72. Right, so now let me run the job again. So now we have 4 files, so you will see 4 yarn childs. Let's see, application master came up on DN1 this time, all together a separate node. Last time it was coming on DN3. Right, so now yarn child came up here. Right, so it will all be decided by the framework depending upon the available resources on a node and locality of reference. Okay, so this is what yarn 2 is, right? So another difference which yarn 2 has from a Hadoop admin perspective, what advantage it has, right? So we have done the demo here. Okay, so what is the advantage here? One was, in the case of mapper 1, job tracker was doing everything. Single point of failure, I cannot do high availability. Heavily loaded because it was doing scheduling, resource management, job submission, job failure rescheduling, everything it was taken care by the job tracker because everything was talking to job tracker back. But in yarn that is not the case. Resource manager is delegating a task to application master, and application master is taking care of running the job, scheduling the job, taking care of failures. Only if the application master itself dies, then resource manager comes into picture. So it is kind of delegating at work. So these are the components we talked about: resource manager, application manager, which will be running on resource manager. It will fire the jobs to the node manager. Node manager will contain an application master, and it will create a yarn container which will actually run your MapReduce job. Right. So this is the flow which we discussed yesterday. What will be the sequence, how it runs, right? And what are the component it has. Right. There are a lot of details into it, right? Although, right, there are a lot of details how it goes, what are the intermediate stages. So I will show you the intermediate stages in performance part, right? But it's a very vast framework. Submitting a job, resource manager goes to a node manager, creates a container, application master, right? And a lot of details which goes into it, right? But let me explain you one very important thing from a Hadoop admin perspective. What is the advantage of having a yarn framework? So if you remember in our previous classes, in Hadoop 1, let's say I have a name node and I have, let's say, for the sake of simplicity, 4 data nodes. Each data node has 8 GB of RAM, let's say, excluding OS and all that, right? Let's say entire 8 GB is available for my computing for MapReduce on each system. So 8 fours are 32. Total I have 32 GB of RAM, right? So let's say I'm an admin. So I will calculate now how many mappers I can run on my cluster. So if I say, if I give 1 GB for each map slot, right, which is configured by mapper dot map dot mb dot memory is equal to 1 GB. right? Again, refer class 3. We have talked about this parameter there. So let's say if I give 1 GB for each mapper, so I, as an admin, I will say, okay, I can run 32 mappers in my cluster, right? So I will say I have a capacity of 32 mappers. So we say it slots, right? I will say I have 32 map slots on my Hadoop cluster. Everything is fine. My cluster is running. So now what happens? Let's say there are users. Let's say Aman is one user, right? Let's say Rohit is another user, right? And let's say this and one more user, right? XYZ. I have given Aman 8 slots, Rohit 8 slots, and XYZ I have given a computing capacity of, let's say, 12 slots. So I have given 28 slots total, right? I made a calculation that my cluster can support 32 slots, 32 mappers, and I can allocate to user Aman 8 slots, Rohit 8 slots, XYZ 12 slots. How we do this? Anybody remember this? How we do this? I'm not sure because I'm not seeing any emails coming, because and I am not sure whether people are actually practicing. Do you remember how we allocate A to Aman, A to Rohit, 12 to XYZ user? We have done a concept of schedulers in which I told you about fair schedulers, and I told you how to set up capacity for queues, right? Over there we will set this capacity for each user. So now I'm saying 28 I have assigned. Everything is fine if 4 nodes are up. Now let's say if one node fails. Now I'm left with only 24 slots because 8 GB is gone for me. Now what will happen to these users? If all users come and start asking me, they will not get their slots, right? Let's say Aman and Rohit come, they will get 8, but XYZ comes, he will not get his 12 slots. Only 8 slots he will get. So how will I adjust that, right? In my config file, I cannot say that one node went down, so I will go quickly and modify my config and change the capacity, right? So this is a nightmare for an admin. So that's why we always run homogeneous clusters. Homogeneous cluster means so that my calculation is easy. All nodes have the same memory. So what will happen? Let's say if one node has 8 GB, other has 12 GB, some has 24 GB. What I have to do is I have to manually do again the calculations saying I have 10 machines 24 GB, 2 machines 12 GB, 30 machines 8 GB. So I have to calculate the total slots I have manually in Hadoop 1, because in Hadoop 1 I'm talking in terms of number of slots we have, right? But in Hadoop 2 I do not care about this. The Yarn framework, what it does, it takes care of this scheduling capacity automatically. I will talk in terms of percentage. I will give Aman 10%, 10%, 4%, let's say. And my yarn scheduler will automatically adjust the percentage according to the available I have. Let's say if I have 10 nodes up running, 10% of that will be given to Aman. If one node fails, remaining 10% of the remaining resources will be given by yarn automatically. I don't need to give explicitly number of slots. So this makes life little bit easier for Hadoop admin. I can have machines with multiple configurations, 8 GB, 24 GB, 64 GB, 128 GB, because yarn itself will calculate for me the total capacity I have for my Hadoop cluster. Makes life little bit easy. Let's clear this. So this is yarn. Now let's go to another very important part, high availability. So here what is happening, I have only one name node And if this name node fails, right, let's say if I stop hadoop-daemon.sh stop name node, right, let's say it failed due to any reason, daemon went down, or if physical node crashed, it will go down, right? So I cannot do any write operation or read operation, does not matter, right? Cannot connect to name node. So name node is a single point of failure. So how will I avoid it, right? So let's set up high availability. I will stop DFS, I will stop yarn, right? So there is high availability at both layers. I can set high availability for HDFS by setting 2 name nodes. I can set high availability for resource manager by setting 2 resource manager, right? Concept remains same. So let's start with node name node high availability. So for that, there are two ways of setting high availability of a name node. One is using NFS, means I will configure a shared NFS filer. It could be a storage file. When I say filer, it could be a NetApp filer. It could be another server which is acting as an NFS server and presenting a NFS mount. And that will be mounted on both servers, both name nodes. And I will bring up the services and I will say to data nodes also that there are 2 name nodes. One will be active, another will be standby, right? The active one will be doing read, write, both operations for the metadata, right? If I go to name node, currently ls-l slash data name node current, here you will see edits and fs image. Edits is the journal. So this will be written to where? To a common shared location as well. In addition to writing it locally, I will be also writing to a shared location. So whenever NFS is writing something to the edits journal, whenever I'm doing write, it is going to shared filer as well, which is read by the standard by name node as well. So it is constantly updating itself. So in case this goes down, I can fail over, right? I can fail over. So for that, what will happen is I should make sure the writes are happening to NFS as quickly as possible. What is that? No lock and sync, right? I will show you that. So for that, first of all, what we have to do, let me close this. And let me start one more name node. Let me bring it here, right? So now I have NN1, NN2, two virtual machines, NN1, NN2. Cat etc red hat release. I'm running 7, right? My other cluster is running 6, CentOS 6. Does not matter whether you run CentOS 6, CentOS 7, does not matter as long as you can run Java. It does not matter for Apache Hadoop, right? But certain distributions like Mapper and all, they have not tested on 7. But in production, we are still on 6.6. So what I'm doing here, ID Hadoop user should be there on the new machine. tf-h, let's see what I have. Currently I do not have anything, any directory or anything, right? First of all, what I have to do is I have to configure an NFS server. So let's configure my repo server as an NFS server. Hostname right? Let me configure this as an NFS server. So in our CentOS or Red Hat, I can simply do yum install NFS server and it will install. In case of 7, it has become utils package. I will do -i and it will install. Okay, it's already installed by default, right? But if it is not, it becomes part of that NFS server. So I will say system ctl restart NFS -server, right? So NFS will be up, right? NFS is up. Second thing, I can also do this service NFS restart, right? Does not matter. The old way, NFS server is running. Vi etc. Okay, before that, create any directory mkdir/nfs. Let's call it NFS. I created a directory. It could be a hard drive mount point, whatever. Change ownership to Hadoop. Whoever is the user which is running Hadoop. So I created a directory which is empty. Owner is Hadoop. Vi etc export fs. I open it. I say NFS. All can mount, but in production I will give only name of and name node 1, name node 2. But here I'm just giving both read write sync. So I'm making sure whatever is written, it is immediately written to disk. It should not be buffered. I'm just doing a sync read write. Save it, exports fs -a show mount -e hostname. Right? It is saying this is available. Correct? So now I go to my client, which is NSO and name node 1. Name node 1. So let's start with the configuration on name node 1. cd Hadoop etc Hadoop vi core -site. Let's open this file. What changes will happen here? Okay, I think we should take a break here because we are in the middle of our class. Let's take a break, come back, and we'll start with the configuration of name node high availability, right? So let's take a break of about 3 minutes and be back, and then we will continue. Okay, so let's continue. So now we will be looking at high availability, right? So we are setting up two name nodes, NN1 and NN2, and I will be setting high availability for them, right? So I'm first of all I'm sitting on name node 1 core hyphen site. So how it will change? First thing will be here I will not be saying anything specific to any node, right? I will not be saying nn1.cluster1.com or nn2.cluster1.com. I'm not be saying specifically to any of the machine. I will just give it a string. What string? My wish. Any string you want, right? Here let's say I'm giving my cluster, your name. I can give my name Aman, Rohit, does not matter. Any name I give it here, I will save it. Vi htfs hyphen site. I will open this. In what will go here? First parameter will be same, where it will store my metadata. Same thing. What is the replication? Everything remains same. Now, what I will add here? I will add the same string name what I have given in my core hyphen site. Let me save this, come out. Core hyphen site, I have given a string, my cluster, which could be anything. But how I link that string to name node? I'm giving a parameter called dfs.nameServices, and I'm saying that is my cluster. So whatever I give there, same I'm giving here. So it is kind of matching that, mapping that string, right? So now next thing I have to do is I have to tell that my cluster is identified by a string called my cluster. Which are the members of these two cluster? I will say nn1, nn2. This nn1 do not confuse with the host name. This could be anything. This could be x comma y, right? They are simple names. It will be more clear. Let me paste these two entries. So what I'm saying here is nn1 is what? dfs.nameNode rpc address my cluster, whatever string I gave, dot nn1 or dot x. I could have given dot x comma y. So I will write dot x. What it is? The actual host name. Now it comes. What is nn2? nn2.cluster1.com port, right? So I'm telling that this string has two members, nn1, nn2. I will explain you where it will be useful. Whenever I'm firing a command, I will say just nn1. I don't have to write the full name. So I'm just kind of giving an alias. I can write x, y and saying that is what? nn1, what is nn2, right? This is RPC service. So as I explained, there are two types of services on which Hadoop talks. One is RPC for communication between daemons, and for data transfer it uses HTTP, REST API call over HTTP. That's why each of the daemon runs a web server, right? Class 3 again. So I copy this. Now same thing I need to do for my web servers, right? Each of the name nodes, they run web server on port 50070. So that's what I'm saying, that the port web servers are running on this port. The actual communication, the command firing is happening on RPC channels, but data transfer will happen on HTTP. Means whenever it needs to pull and edits or write and edits, it will use HTTP. Similar to secondary, right? Secondary was also doing the same way. When it was doing checkpointing, it was going to primary, pulling the edits and FS image, doing checkpointing, and pushing it back using HTTP. Class 4, right? Then I will say where it will write the edits log on a shared filer. The NFS mount point, it is my wish, I can give any path. It is, let's say, MNT filer, right? This is done. Then there is one class which I have to put into, which is called HA configured failover proxy provider. What this class tells, when the data node is talking to, let's say, NN1 and failover happens, so data node should know that switchover has happened. I have to go and ask now name node 2. So this is a kind of a failover provider which does two things. One, it helps in switching over services from one name node to another name node. Second, it tells the data node by firing a command when data node contacts it that failover has happened. Now go and talk to another machine. That is the one active now. This is all what is required, right? After that, the parameters are optional. My wish, right? I can put this if I want. So what these parameters are after this, right? These are optional. What these parameters are telling me, my fencing method. I'm saying SSH fence. What I'm telling is when, let's say, I do a switchover from NN1 to NN2, right? How we do, we'll come to that. It should go and shut down the daemon on the other node if possible, right? Let's say if NN1 failed physically, then it cannot do, right? But if it is able to SSH, so I will set up a passphrase-less access between NN1 and NN2, and it will just go execute a shell command by shutting down the name node, right? This is not mandatory, optional. This is done. I will save it. Now cd back, I go to name node 2 empty, right? So what I do, scp-r hadoop 2.6 192.168.1.71. I'm copying it. I'm copying it here. Okay, Zookeeper, forget about that. It does not comes into picture now. Let me run it here also. Zookeeper is currently not used anywhere. Right, this is from some another lab. So I will do here vi.bash profile. Same thing I will put here. So here everything we are doing manually, but in an actual production system, this all will be deployed from a central configuration server. Okay, Java is not installed. So let me quickly install Java also. Let me see which JDK it pulls. Okay, it's pulling 75 only. Right, I've copied a JDK package into my repo. Not signed. Hyphen no GPG check. I think this is the parameter. Because this JDK is not from Red Hat, so that's why it's prompting me. So I'm saying no GPG check for it. Right, so it's installed. ls-l/user java, right? It is there. So now df-h. I have to create the same directory structure, right? I have what directory structure I have created here on the primary name node /data name node, right? Same means why same? Because in the config file I'm saying that way, right? This way, data name node, right? I have to create there that same one here. So let me see whether I have hard drive or I can create a single folder. Okay, I have SDB. So what I will do quickly, I will do fdisk on that and quickly create a partition. Currently nothing is there. Create a partition, primary partition. I'm saying one, give the entire space, and I'm saying commit, right? And then it will create one partition for me. I'm doing an mkfs on that, mkfs.ext4, right? And then I will create mkdir/p/data/name node, right? And I will mount this there, mount /dev sdb1, right? I'm going a little bit rapid pace here because most people are from Linux background, so they understand what I'm doing. I'm just mounting it. Then I'm doing change ownership hyphen recursively to Hadoop :Hadoop on data, right? So now I can see that I have a mount point, same mount point here, su hyphen Hadoop cd Hadoop. Okay, I have to now do ln-s Hadoop to Hadoop cd Hadoop etc Hadoop vi htfs -site, correct? So it should be same here, whatever I have given in the file, right? It is not that I'm saying if on primary name node I have /data name node, second name node should also have. No, it is according to the config file, right? Here config file I've given that parameter, so I'm giving the same one. Save it. Right now what I have to do, exit. I have to create a mount point also. Which mount point I have to create? vi htfs inside, right? So I'm also telling it that there is a filer location. I'm telling where you should write edits to the name node. I'm saying it's a shared edits. When I put the keyword shared, it understands that there is a locking mechanism named shared.edits.dir. So I'm saying it will be mount filer. So what I have to do is mkdir/mnt. It can be any location, doesn't matter, filer. Same thing I will do on the other one. And I will do change ownership mnt filer, both locations, right? So I do mount now. See, that is nothing is mounted. df-h, right? I do not see that mount mnt nfs. So what we'll do now, mount, first of all let me do show mount whether I can see that or not. E 192.168.1.254, I can see nfs mount available to me. So I will do mount -t nfs option I will give read, right? -no lock, important, right? No lock 192.168.1.254 :nfs. I'm mounting it to mnt filer. So it is mounted. You can see it is mounted now. ls-l/mnt, I can see filer is mounted. So same thing I can do on my other machine also. It is mounted. So now before starting in, let me see whether I can write or not. As Hadoop user, I say touch mnt filer test. Another node I go as Hadoop user. Can I see that? Right? Can I modify it? Right? Let me see. Cat mnt filer test. Everything is fine. Let me see. Can I delete it? So everything is fine. So one important thing which we have to keep in mind while practicing at home, the UID should be same. UID of Hadoop is 1003. Same should be on the another node. Same should be on my NFS server. Right? In production, it will not be a problem because everything will be coming from an LDAP, a common repository, common user repository. But in at home, I might add users in different sequence. So some IDs might differ. So this is very important from high availability perspective. Both name node have same UID, same ID for Hadoop user, and the NFS also have the same ID. I verified this by doing read write NFS. So everything is fine now. So now mount is done. So now what is the first thing I will do? rm-rf. Let me remove the old data I have from name node. I'm removing it. So currently data name node is empty. ls-l-mnt filer is empty. Both are empty, right? And obviously on the second one it will be obviously empty because this name node was never there. I created it new, so it should not, it will not have any data. Everything is fine now. So the very first step, choose any of the name node. nn1, nn2 does not matter. I will say hdfs name node hyphen format. Your wish, any name node, nn1, nn2. See, it is saying successfully formatted. These two lines. So here you will see now data node is empty on name node 2, but filer will have an entry, correct? Because filer has been formatted from the other side, right? I am on nn1. nn1 has data here because I executed the format command on name node 1. So if I go to current version, cat will be, if I do, right? It has done, given some number, done some formatting. ls-l/mnt filer current. It has some version number which is commonly read at both locations, but data is empty. So I will not execute format command again here because if I do that, my cluster IDs will not match. Cluster IDs will not match. So two options are there. One, I will manually copy the current directory which I have here. Right? I have two options. Either I will manually copy this current directory to the second name node, or I will use a bootstrap command. Right? I will use a bootstrap command. So what is a bootstrap command? Bootstrap command is used for booting your secondary machine from the primary from the other machine, right? So I will go to the other machine. I will say hdfs name node bootstrap standby. This is standby. It does not have any metadata. The moment I hit enter, it will contact my its counterpart, pull the metadata everything from the other machine. Oh, sorry, I have not started it. I'll say Hadoop daemon dot sh start name node. Primary one I have formatted, started the name node. Second one, which is standby, I will execute the bootstrap command. See, everything get picked from there. Has been successfully formatted. So now I can see this will also have dead data. Now JPS here, Hadoop daemon dot sh start name node. Name node is running. Both name nodes are up now. So now there's one more interface I have, right? I go to any name node, I say HDFS HADmin. Here I can say I can get the service state. So the name which I given there in the short form in the config file, it is handy here. So I'm asking, what is the state of NN1? What is the state of NN2? Both will be standby initially. Why? Because there are no data nodes. We have only started name nodes, right? Configure them, and there are no data nodes yet, right? So what I have to do is I have to manually put one of the name nodes into a active state. How I can do? Either I can say transition to active, which one? NN1. Your choice. Which node you want to start to an active mode. It has become active, NN2 is standby. Correct? Now, this is done. Now let's go to data node. Name node are configured. Now we have to configure data nodes. SCP-R Hadoop 2.6. I'm copying to 192.168.1.72. So let's connect to 72. Let me shut it down. It will save us resources. Let me go to 72. Right. So it has copied the new files. cd hadoop etc hadoop vi core hyphen site, right? vi hdfs hyphen site, right? So now here I have to change that parameter dfs.data.dir. Same thing here, dfs.data node data.dir, and this will become whatever path I have, d1 space, right? I can give multiple, but let's say I am giving only one. Cluster services, which is my name node 1, name node 2, that's all. Over here I do not need to give web server addresses and all that. So what I have to give here is, I don't need to give all this fencing to data nodes, right? This is only for name node. If need be, right, I will remove all this. I remove all this. I do not need anything related to filer. I do not need anything for web servers. Right? So this is a very simple config file I need. I'm telling where it should store data or for data node, what is the replication, and it should understand when I say my cluster, it should understand two members it has, and these are two members, right? And the proxy failover class. I save it. You don't need to worry about copying and noting down anything. Everything is in the GitHub. You go back, you go to HA, you will have everything here. Core hyphen side, both name nodes, data node, HDFS hyphen side, name node, you will put this, data node, what you need to put, right? You have to change the host name accordingly to your setup. Okay, so now JPS, nothing is there. I say Hadoop hyphen daemon.sh start data node. Data node is up, right? So let me write some data. Hadoop fs hyphen ls. Let's write some data. ls hyphen l Hadoop put new file. I'm writing that file to HDFS. File is there. I can cat this file. Right? And my, which one is active? And then one is active. And then two is secondary. So let me show you the commands now. Now I have, how I can do, I can say transition to active other one, right? And then two, right? So now when I'm saying transition to NN1, what it is saying, already I have a machine which is already active, which was NN1. I cannot do a transition when one active, when I already have an active one. Forcefully I can do, but that is not the right way. So I have a command which is called failover, right? So let's say if I want to do the transition command, what I have to do is first I have to transition my NN1 to a standby state. Then I can only transition it to an active state, right? Or what I else what I have to do? I have to do failover NN1 to NN2. I'm saying failover NN1 now to NN2. Failover is successful. Data nodes are talking to both. This is high availability. I will have a manual intervention here. When I say manual intervention, you can obviously script it out. You can check for the port services up, execute a fire script, which will do this command for you, right? This is a manual way of doing a failover. Any questions you have here? Any questions you have, you can ask me, right? Stand by. Now, NN2 is active, right? So now the ls-l/mnt filer is having all the data written. Add its written. right? So now when you set up high availability, you don't need to run secondary, right? Let me explain you. In in Hadoop 1, what was happening? If I'm running a primary name node and then one, what I have to do? Edits is the journal, fs image was the main image. So the checkpointing means the edits were not empty to fs image unless and until checkpointing happens. So how the checkpointing was happening? Either I have a secondary name node which will go to the primary, pull this to itself, merge it, send it back, or I have to restart the name node on the primary system, right? Not recommended in production. That's why we will always have a secondary. But in name node 2, or sorry, in Hadoop 2, whenever I set up high availability, right, and I have two machines, they automatically, the standby node will act as a checkpointing node for the primary node. It will keep on doing the checkpointing. So what will happen is, let's say I have two nodes, as we have nn1, nn2, nn1 is active. This is standby. So it will automatically do checkpointing. I don't need to worry about checkpointing or my journal growing very big. Let's say failover happened. I failed over to this. This is active now, and this machine is out. Then I have the same scenario here. Same scenario here means the edits will keep on growing. So I might put a secondary name node here for me to do it. But there's no advantage. Why? Because anyway, instead of putting just one hardware just for checkpointing, why not put high availability, two nodes, right? So in production now, secondary is gone. We will always be using high availability, which will be active and a standby rather than active and a secondary. Okay, so this is manual failover. This is what we are doing. You've seen the demo. Another way is using a Zookeeper, means automatic failover, right? So what is automatic failover? So I explained you the concept yesterday, that we will put odd number of nodes which will be acting as a coordinator, and they will vote among themselves and arrive on a decision. What will be the decision in the case of Hadoop? They will do a voting among themselves and decide which one should be active, which one should be standby. So this is how it will happen. Active name node, standby name node. There will be a quorum journal manager, means there will be a quorum mechanism and there will be a one quorum manager which will be controlling this mechanism. Election will happen. One will be the writer, other will be the reader. Journal node will be the nodes which will hold your edits. What will happen? Instead of having a shared filer which is having your edits log or metadata, now your metadata will be taken care by the journal nodes itself. Means I will now copy this metadata which was going to NFS location, will now be returned to three journal nodes, right? These three journal nodes, it is my choice. It can be part running on the same machines, name node, job tracker, data nodes, or I can put separate machines for it. They are very lightweight daemons, right? So in production, what we do, we run them in co-location with other daemons, maybe on the name node, maybe on a job tracker, right? For a testing purpose, I can run all three instances on a single node. Means I can create three directories, run three daemons, give them three separate ports. They all can run on a single node, right? But I will show you how we'll run in production on three different nodes. So I will do journal node. What is a journal node actually, right? Instead of having an edits filer, where both name nodes were keeping its metadata or the added journal, I am now saying I'm configuring 3 journal nodes which will keep my metadata. 3 nodes which will keep my metadata. Why 3? Because in case journal node itself fail, I still have metadata somewhere, right? And they will do election among themselves and decide on which one should be the active one. It's a coordinator, right? So in Hadoop, we use Zookeeper. Zookeeper is used widely in many places. Zookeeper is a service which maintains configuration, naming, and distributed synchronization. I can also push configuration by Zookeeper. For example, what I can do is, let's say I run 3 servers and I ask Zookeeper to monitor a directory. Let's say directory is slash data. I write some files in it, F1, F2. I can use Zookeeper to sync these files data across multiple nodes. The moment I make a change here, F3, it will also be visible here, right? I can do multiple roles of a Zookeeper. One is this. Other is the coordination. Coordination means Zookeeper will coordinate the services. I will have 3 nodes, Zookeeper nodes, which will talk to some server, in our case name node, and look for services, whether they are up or not, and they will do an election mechanism among themselves to make a decision which one should be active and which one should be a standby or a passive, and they will decide on that behavior. Okay, so now let me show you how we will set up that. Zookeeper has lot of details. You can refer the Zookeeper side, or I can tell you a little bit detail here. For example, let's say I'm running 2 name nodes, NN1, NN2. So what they will do, 3 journal nodes which I'm running, all 3 will pull edits to itself to keep a copy of it, right? So the concept is similar to how DNS works, master slave works, right? DNS master, whenever we make a change, we bump up the serial number so that slave side knows that its serial number has been incremented. So I will again do a zone transfer. So similar to this, same thing journal nodes do. What they do, let's say I have a journal node 1, 2, and 3. Journal node 1 will go to name node 1, pull the edits and update its counter, saying counter 1. Second will go pull the edits, it will say counter 2 with the timestamp. Third will go pull the edits, say counter 3 with the timestamp. And they will have a quorum manager, a journal manager running. They will be talking to each other and they will be saying the timestamp, who has the latest copy, right? And they will know who contacted the name node latest, which is the latest copy. So let's say journal node 1 went, 2 went, and by the time 3 went, name node failed. It was not able, when I say, it could be any reason, network not reachable, name node, any component failure, daemon down, not able to pull edits. What it will do, this journal node will ask other nodes what version of edits you have. Its count will be higher than this node, right? So these 2 nodes will win the voting, saying we have a latest copy than as compared to you. So failover should happen. Now other question comes, what if the issue was with the journal node itself, right? So what happens, before actually doing a switchover, These two nodes again will do a check by reaching to the name node. See whether the fault was only with this node not able to reach, or we are also not able to reach, before actually doing a switchover, right? So switchover, there's a class which is called to do a Zookeeper switchover. So how we will set up this, right? Let me show you that. First thing is, I will go to, you can use my GitHub reference HAJQM, right? I have given the steps also how we do and how we will set up that, right? But let me show you that. First thing is, I will go to Google and I will say Zookeeper download. Download, download, go to the mirror, right? I will take a stable release, which is 3.4.6. So I have downloaded that in advance to save on time. I'm sitting on name node 1, right? So I have Zookeeper 3.4.6 with me, right? So before that, let me stop Hadoop. Stop data node. Oh, sorry, I'm running on the wrong machine. So first task is, I will take this Zookeeper tarball, I will untar it. Where? Anywhere, but we are using Hadoop home, right? So I'm using, my Zookeeper should also run with the same user ID with which I'm running Hadoop, because otherwise it will not be able to fire commands to my Hadoop cluster. So that's why I'm going writing there. So I will say change ownership uh, to home Hadoop, and I will do unmount of MNT filer from both machines. So I've removed them. So now first thing is, I have to set up Zookeeper. ls-l cd cd to Zookeeper directory. It will have same directory structure, bin, config file, and all that. Right? Bin will have binaries, commands to run, cleanup, and all. Config will be the directory which will have the configuration files. So here what I will create, zoo.cfg file. What it will contain, let me go to my GitHub. Instead of typing it, here I will copy first thing is, I'm saying tick time, right? The tick time is the time how frequently it will do the synchronization. It's milliseconds. how much it's kind of a timeout, right? So main thing is where it should keep the data dir, I'm saying slash temp zookeeper, where it will keep the coordination data. What coordination data? It will be coordinating with each other and saying who is the master and whose uh, decision we should agree to. And then I'm saying which three nodes will be my zookeeper server, right? Odd number of nodes. I'm saying nn1, nn2, and another master, which is job tracker. And I'm saying which is the port range, right? When they talk to each other, what is the port range they will use for source, send, and receive. And the client port is 2181. Means I configure a Zookeeper setup with three nodes, and who will be client for me? Hadoop name nodes. The Hadoop name nodes will go and talk on 2181 port of Zookeeper servers and ask for or listen for commands. Save it. After this, what I will do, ls-health/tmp mkdir, I will create a directory mkdir-p zookeeper, right? And inside this, I will create a file myid. Myid, what it tells is, myid is a file which will tell me what is my identity. Means when I'm running three zookeepers, one will have identity one, other will two, other will three. So they will understand who their identity, who is whom, right? So when Zookeeper service talk to each other, it will say I'm talking to you, my ID is 1, my ID is 2, right? So they will have a unique identifier. So I will copy this scp-r Zookeeper. I will copy to 192.168.1.71, and I will copy to 69. Now I will take the same command. I'll go to other machine, coas user Hadoop. I will execute this and I will say my ID is 2. Oh, I have not created that directory. Right? I will go to another node, create this. I will say, oh sorry, I've created on the wrong machine. Echo 3, job tracker 3, ls-l. Right? So now I will say Zookeeper bin jk server.sh start. I will execute this command on all three Zookeeper nodes. So I say I've started Zookeeper service is saying started on all three nodes. Right? All commands I have given here. Right? So I can see the status. Right? It is the follower. Let's see who is the master here. It's the follower. This is the leader. right? So this is the leader, and the voting happened between them, and this one, so this became the leader, other two became the follower. So now leader will one who will take the decision, right? It will say what to do. Now let's go to cd hadoop etc hadoop vi core hyphen site. Let's open this file. So what change will happen here? Let me close all these configs. I'm saying same string. Now I'm putting one more property. I'm saying high availability Zookeeper quorum will be maintained by three nodes, NN1, NN2, JT nodes. And these are the port where you can connect to, right? Same thing is available in my GitHub as well, right? And this is SDFS-site. So in SDFS-site, what I will put? Same things which I have put there. Everything remains same, but now I will add automatic failover enabled. And what is my quorum? Only vi SDFS-site I open. All other parameters remain same. Services, membership, which is my web server, everything remains same, right? But in addition to that, what I will do now, I will now remove this. I don't want shared filer now. Remove that. Here what I will add? I will add automatic failover property. And I will say, instead of saying shared edits directory, now I'm saying there's a journal nodes edit directory which is at this location, right? And I'm saying that DFS name node shared edits directory you can access at this path, NN1, NN2, JT, this port, my cluster path, right? I will come to that. What is this, right? So what will happen is, one is we started Zookeeper, which is a coordination between services and keeping a track for making a decision. Journal node is the node which will be pulling your actual edits file, right? So where I will create this directory /data, I'll say mkdir /p on these three nodes. ch on -r Hadoop :Hadoop, and I will say this one. And what I'm saying here, I will run a journal node daemon which will listen on these port, and it will write metadata into /data my cluster directory. This edits journal which was going to NFS, now it is going at those three locations. This is done. So what I will do now, scp-r, sorry, scp-r, I can copy core -site and SDFS site, right? Rest all are same, 192.168.1.71 tilde Hadoop etc Hadoop. Same I will copy for 69. Right. So now what are the steps I have to do? rm-rf. Let's first clear old metadata. I do not want anything. I'm clearing that. Right. ls-l/data. My cluster is empty on all nodes. So the first step which we'll do is first of all I started the Zookeeper. I configured the core and HDFS file. What I will do is I will start the journal node. Journal node started. Quorum peer is coming from Zookeeper. Empty. Now I will do a format of name node. Which name node? Any one. Let's say I choose the first one. I formatted. Second thing I will do, I will format the Zookeeper FC's failover controller. I am formatting the Zookeeper controller as well. Okay. So let me see what permission error it is giving. Okay. Oh, sorry. I've given a wrong name. jt.cluster1.com. So it's not able to find it. Yeah, here also I have to change. So it's a semicolon separated field here. And I will quickly do a copy. SCP also to 71. Right. So I'll go back and I will do format again. Right. So now format is completed. Successfully created my cluster. Right. This was the directory which we have given. Right. So now I will start the name node on the primary side, first side. I will start the controller right? And then I will bootstrap on the other side, same step which we are doing in primary. I'll bootstrap on the other side, and then I will start the name node. Okay, it is coming up. Just give me a second, let me see what is the error here. Oh, okay. I'm not sure I forgot to format the name node or not. Okay, okay, it's fine. So format, I think format did not happen. So now I will go a bootstrap here, right? So it is done. And now I will start the controller also on the second side. And start name node as well. That's all steps are given here. So name node is up, quorum is up, failover controller is up, everything is up. So if I go to any of the machines now, I say Hadoop or HDFS, HA admin, and then one active, and then two standby, right? And this data node, let me show you, rm-rf slash space t1. Let me clear it, and I will start data node here. Let me start data node. ls-l Hadoop fs-put new file to Hadoop cluster. Right. So now standby is secondary. So what I do is, let me abruptly do any action, right? Not only daemon shutdown, let me shut down the machine. I'm going to secondary. It's standby, right? So let me do an init 0 here. I'm shutting down my primary name node. Means I'm not doing a graceful shutdown of the daemon. I'm abruptly going out, right? So there should not be any manual intervention. right? So it will, okay, one thing I forgot here is our journal node and Zookeeper are also running on the same node, right? So in production, we will not be doing that. Data, my data, right? You can see my cluster directories have been populated. Same path here also. Okay. So what was wrong I did was my other things are also running on the same machine. What other things? The Zookeeper and journal node, everything is on that way. So that's why it went off. But let me bring it back. Right, I will be able to do read operations. Right, see now it is active. So it will take little bit more time if my journal node also went down, because now instead of 3 it has to recalculate the do the election and decide on a winner, right? Because one of the Zookeepers also went down and so journal node also went down. But if in a production, what will happen is we will never keep them on the same node. We will never keep them on the same node. So in that case, it will take lesser time. If I say Hadoop daemon dot sh start name node, let me do quickly history here. One is this, you have to start Zookeeper and you have to start this one and you have to start journal as well. Right, all things are up here, right? So let me show you. The failover will be quicker if I'm keeping my uh, Zookeeper journals node separate from my main daemons, right? So it's like I'm cutting the branch where I'm sitting if I'm running on the same machines. So what I'll do here is currently this is active. So I will simply do Hadoop daemon dot sh stop name node. I'm not shutting down any services, right? So I'm assuming that in production, all other daemons are running somewhere else, not able to connect. It is active. See how quickly the transition happened now. So that is what in production we have to take care, that I should not be running all these things on the same node, right? So this is automatic failover, right? Automatically it will be switching over using Zookeeper. So please refer the sequence which will go. If I do a sequence wrong, it will not start. For example, if I format this the controller before starting a journal node, it will not work. It will not let me do. Your journal node should be up. Why journal node should be up? When I'm doing a JK format, it is actually formatting that data my directory, my cluster directory. So if my journal node is not up, it will not know where to go and format. Right? So journal node should be up. So you have to follow the same sequence. right? So this is JQ demo. Hadoop 2 setup demo also done. So we are left with now Hadoop upgrade, right? Hadoop upgrade. How we will do an upgrade of a Hadoop from one version to the another version, right? So these are the steps I have given here. What is the upgrade process? So this is kind of a take it as an assignment for this week, because we will be meeting after 1 week. Test out the upgrade. If you are not able to do, anyway I will show you in our next class. The very first demo will be on upgrading Hadoop. But please try it by yourself, how you will do upgrade. Follow the steps, follow my GitHub, go back, go to Hadoop 1. So by this, take Hadoop 1, set up Hadoop 1 cluster, then upgrade that to Hadoop 2. Follow this I've given here, right? So this is how we will do an Hadoop upgrade. Please read high availability links I have shared here. This is my GitHub forum with all the config files. You can refer further readings. In our next class, we'll be doing upgrade demo. If you are not able to do, but I advise you, please do it, because I can feel that people are not going through the old classes, right? And it will be of no use if I keep on running through the topics. So please watch all videos again from class 2, 3, 4, 5, 6. First you can ignore if you don't have time. But it's good if you start by first as well. So we'll be talking about Hive, HBase Pig, Flume Scoop. So I will be telling you how to set up them. I will give some use cases, right? For example, we will take some data maybe from Twitter or Apache server and try to see how Flume can ingest that into Hadoop cluster. Then we will do some Hive query on it. We will put it to HBase, do a connection between HBase Hive, put our data into MySQL, right? So I will give you all production cases, how we will be doing in production. I will show you few pig scripts, and I will also show you how to import data from MySQL, which is RDBMS, to Hadoop, right? So for the next class, please read these links. Any questions you have now? Let me know if you have any questions. Otherwise, we will close our today's class. Please refer these talks, these PPTs, everything I will share you. I think I forgot to share the PPT for the last class. I've shared for all previous classes. I've shared the videos. I will share the PPT for the last class and today's class, and also the recording. Okay. So if no further questions, then thank you very much for your time. And I will see you in 1 week's time. In the meanwhile, please set up at least one node cluster on your laptop, desktop, whatever you have, Ubuntu, CentOS, Fedora, whatever you have. Please practice this. Otherwise, it is of no use just going in listening and all, right? Unless and until you will not practice, you will not feel it. Because as a beginner, what will happen is I will be putting some parameters wrong. Like instead of dfs.nameNode.dir, I will be putting a data node parameter on a name node and starting a name node daemon there, right? It will not come up. So I have to understand how those things are working, right? Do not cramp up anything. There are a lot of details into each one. Okay guys, so anyways, if there are no questions, then I will close the session, and I will see you next week on Saturday at 8 p.m. and we will continue our discussions from that. Thank you very much. Bye bye. Have a nice week ahead.